start with this invited lecture. It's my pleasure to introduce Professor Emina Hadžić. She has an extensive experience in the field of water resources, civil engineering, taking the role as independent explorer, designer, supervisor, and site engineer. She has worked almost entirely on the management, design, and supervising of water supply projects, river engineering, water protection, environmental protection, wastewater collection and disposal project, solid waste project, as well as some hydrodynamic aspects of the global problems of water resources, groundwater, and modeling. She has worked as a consultant for the Ministry of Economy, water resources sector, and she is the leader of the new master course in the field of protection against natural disaster. She carried out more than 60 domestic projects for the Ministries of Transportation, Environment, Water, Industry, also local government and municipalities. She has also published more than 70 professional and scientific publications, including 5 books and 5 book chapters. So please join me in welcoming Professor Hadžić in the talk Integrated Risk Management of Water, Energy, and Natural Hazard System in Southeast Europe.
Good morning to all of you. Firstly, I'd like to thank for the invitation on this conference. It's really a great pleasure to be here today, especially after 2 days very interesting presentations. And as I'm a professor, I see so many young scientists. That's very important to see excellent presentations, excellent presentators, and thank you for all that. Today, I will speak about integrated risk management of water and energy systems and natural hazards. Focuses mostly on the Southeast Europe. As engineer, I divide my presentations in 4 parts. Firstly, I will talk about problem framing, explain why this topic is important, then give some evidence and impacts, pass through some real case study from climate change impacts to impact on water resources, and give some real evidence in Southeast Europe and a little bit wider. Then come to integrated solutions, and at the end, I hope, give some recommendations. Why I think that this topic is very important? Because when we look at climate-related hazard, there are no longer looked as isolated events, because their impacts are spreading through all sectors, through water sectors, energy sectors, spatial planning, environmental sector, food, agriculture, every type of sector. And in Southeast Europe, we have real evidence of their negative impact through droughts, floods, and the other natural hazards which affect not only Southeast Europe but almost all the world. And this is the reason why I think that integrated risk management isn't only technical task, not only technical task. It needs to become governance priority for this part of the Europe. And integrated solution must link all these sectors. We shouldn't look at the sectors by alone, like separate cells. We look at this all together. This slide is very important. I know that you already know everything what is on this slide, but it is very important because there is differences between left and right side. Left side shows us long-term trends, land and ocean temperature from 19first till 2024, and the bottom line shows us how intensify global warming is evidence. But the right slide is very important because it shows us the recent 30-year trend that is much more stronger and more especially pronounced all over the world. That means the global warming is reality, especially in the last 30 years. And this slide just reinforces previous what I mentioned. Previous slide showed like just one cross-section all over the world. But now you have, you could see global ocean average temperature and land average temperature. Celsius per decade. But if you look at the scenario, middle and the worst scenario, they show us that the temperature is rising in Europe. What is meant for water resources? Water resources is very important because if we know that if a degree temperature is at 1 Celsius degree, if we have, that is mean about 70% more moisture in the air. If you have more moisture in the air, that means unstable climate. If you have unstable climate, that means more heavy rain, more droughts, more floods, more everything what we don't want to see in our cities, in our countries, everywhere in the world. And that means I like to mention sorry, that integrated risk management is need to be priority for our governance. If we think how it looks and how climate change impact affect water resources, I know that these pictures are very known everywhere in the world. In the media you can see everywhere the same pictures. If you have scarcity of water, we have a picture like on this part. Problem with water quantity. Also, we have problem with water quality. Very often, situation in our river is something like that. And I especially mention water-related hazards. If you look at water quantity, we couldn't separately look at problem water quantity or water quality problem because if you have drought, it means worse water quality, means more water pollution in that cases. If you have more floods, it also means public health is increasing or treatment is public health because problem with floods is very often followed by some epidemic and similar things everywhere in the world. And what is very important when we look at water quantity and water quality, this slide is maybe very often for people from hydrotechnical because it shows some hydrogram river flow. Very useful, similar for the mostly river in this part of the world, for the Southeast Europe, which means that we have 365 days, and this blue line shows us how many flow, how many water we have in the river. We have summer period after snow, and we have maybe more water in our river, but in the summer period and first autumn, there is big differences between two lines. Blue line is how much water in the river we have, but dot line shows us how many water we need from our nature, which means that in this period and this period we have problems with too much water. But in that period we actually don't need too much water because it's winter. In this period, if we have summer, of course, and the beginning of autumn, in that period we need water for agriculture and all our needs. That means that we have a really big problem. If we add to this diagram climate change, land use changing, activities which are mostly unplanned everywhere in my countries, but I think very similar situation is this part of Europe, and we could say that we really have a big issue regarding water, because we need, when we talk about water, we need enough quantity of water, but also we need enough good quality of water. But we have a problem with two components of the water. And I call this mismatch between valuable water resources and water demand. How look situation in our urban area? We know that urbanization is a global trend. And when we look at global warming and impact on water cycle, we could say that water cycle is intensified, but when we look at urban area, it also structurally changed because of land use. And this slide made you know that, but it's very important because it shows us, for example, if you have 100 of precipitation, if you have natural ground cover, almost 55% go into the soil, which is good for us, of course. But when we continuously urbanization, and the last scenario with the most, if we have 75 to 100% impervious surface, that means that we urbanize all our streets everywhere, concrete, asphalt, and so on. In that case, we have only 15% of infiltration. What does mean? What is important? 55% of our precipitation is surface runoff. Look at this, 10%, 55%. What's happening in our city today? We have, after intensified rain, we have always floods. That doesn't mean that old grey infrastructure is bad, no. But they designed with the historical data. We need maybe new data. We need maybe new scenario to rebuild or to redesign our grey infrastructure, our drainage pipe, water system, and so on. Maybe we need different input for that. And what is important also to say, mention, that in this situation, we need natural-based solutions. We need maybe things about sponge city and that solution, because from my point of view, we couldn't think only about nature-based solution and say, yes, this is the best, this is something new, this is something no. Isn't true from my point of view. Combination green infrastructure and new green infrastructure give us the best result. We need to use all our infrastructure and add something new, but we couldn't add something new if we don't know what's happened in our land. Because of that, we need integrated risk management, means that we need use spatial planning and include all our sectors together and prepare some new plan for building new water supply system, new land use file, everything, better plan. Now, my famous pictures show us, if someone is from Shanghai, please raise your hand. Shanghai, 1989, nice fisherman place. 15 years ago, it looks like this. And now, like science fiction. But similar situations everywhere in the world show us that we need to really think about water sensitive urban planning, because we say that urbanization is global trend in Europe for maybe 15 years. We expected maybe 80% of the population will live in urban area. That means that for all these citizens, we need water supply, we need quality water, we need quantity water, we need to waste disposal, we need new water treatment plant, and everything is changed. This is important to mention again, that we need only together cross-sectoral thinking. And how to come from global climate change to local risk. And just look at my time. From global signal, if you have, for example, rising temperature or atmospheric moisture and so on, the same climate signal has the same impact on the different regions, because they affect, because the signal becomes a risk only that interacts with local exposure and vulnerability, which means that in our situation, we need to prepare our society for this impact, to better preparedness. We need to better plan how to prepare our citizens for this new scenario. And of course, the same climate signal, summer can lead to extremely distorted floods with so many human losses. But summer, if land of citizen of city of society is prepared for that situation, maybe we will have less economic losses, we will avoid totally human losses and so on. This is the most important, to build resilient society. This is our main goal. How our citizens need to be safe everywhere in the world. And now, I will move through a few case study. First, what I choose is so many cumulative rainfall reached about 930 millimeter, and this event show how extreme rainfall can trigger cascading destruction. This is very important across transport, water system, and agriculture. Next example is Storm Burgas and the Alban disaster. Storm Burgas affect Central Europe, and they shown that overall losses were almost 4 billion euros. And local disaster was local tragedy in my country in 2020. I will say a little bit more about it. Next, 3 events are from Southeast Europe. It's Burgas tragedy, Venezuela in 1999. Look at this number. I don't want to say this number. 19,000 deaths. I found after this disaster that is assumed maybe about 10,000 and 30,000 missing people. Do you know what is 30,000 missing people in this area after this disaster? So big number. Then European heat wave, 2003, 35,000 exceeds deaths. Then it is very important, California drought. California drought, maybe 10 years California drought, I will say a little bit more. Water scarcity, disrupt all water system, energy system, hydropower, agriculture system, so many negative impact on this part of California. Now I just show a few pictures regarding European heat wave. This slide because I want to show that this heat wave means temperature 3 to 5 degrees below average, somewhere 7 degrees Celsius above average, and probably 35,000 deaths. In France, 40,000, only 15,000 deaths. But I talk about this part of Europe. This is Central Europe. I don't think about my country or Bosnia or Southeast Europe. I think I show you rich countries which already have preparedness system very well developed. Then, as I'm an engineer, I show you some photo of buildings as a result of this drought. Destroyed building as a result of long-term drought in United Kingdom and France. Then I would like to speak about California drought because 10 years of very quickly shift phenomena between extremely drought, multi-year drought, then suddenly, quickly, extremely floods. After that, quickly droughts, and so and the scientific community says that that is now normal. That's feature of the new climate regime. This is important. And the scientific community call this phenomena hydroclimate whiplash, and increasingly recognizing it as a systemic response to climate change. Now, Burgas tragedy and a little bit photo from Bosnia and Herzegovina. Burgas tragedy, which means this is protection. Extreme rainfall affect this part of Caribbean Sea near Burgas, maybe some 100 kilometers exposed coastal area, and with so many disasters, with so many human losses, and so many unsolved situations later, of course. I'm not sure do we learn lesson from these two situations. I could say for my country that we didn't learn lesson. This lesson was happened to 2024. 27 losses were here. The same situation, but smaller area, smaller catchment area. This is maybe 300 meters. What's happened? Heavy rainfall, human activities, deforestation, wildfire everywhere in the catchment area, erosion, then torrential flows, landslide, debris flow, and big settlement impact. absolutely the same scenario. Then I would like to show some accidental slide from Bosnia and Herzegovina, small river between Teslić and Banja. Nice summer day. Children were inside before a few minutes. Look at this. For only a few minutes, river went full of not only water, but also sediment, trees, everything from the catchment area. The result of that is that hazard timing shapes management options isn't the same. React if you have some cases, if you have some rapid onset, or if you have, for example, drought and slow onset, cumulative effect of that. For that case, we need rapid events, early warning system, evacuation and operational readiness, slow processes required, monitoring, land use control, and long-term prevention to avoid these disasters. Nice slide is from our Danish segment project. Show us differences when we look at historical and present segment balance in daily basis. We see big differences. Historically, the delta of the Danube River reached mostly between 40 and 60,000 million tons per year sediment. Now this amount is 15 to 30 million tons per year. What's happened? Not only climate change, but also human activity. We build dam, river training walls, changes our land area without any planning, without thinking about disaster risk, we just think about one risk. For example, in Europe we have flood active, and also because of that we prepare flood risk map. Yes, we prepare that, but flood risk map show us where is flood line. They don't show us what's happened if you have landslide, debris flow together, if you have earthquake somewhere. What will happen in that case? All our activities change river morphology. If you change river morphology, that means we have balance of sediment, balance of river, divorce, water quality, we will talk about it so long because the changes in catchment area has so big impact on our river system, on our river management. And this is, on this slide I try to show that water system, energy system, and natural hazards are interconnected. And, for example, if you have natural hazard, it has some big impact on our energy. If also low flow conditions makes our energy instable, and we have a problem with energy reliability. Also, energy decision, for example, dam and reservoir operation, change flow regime downstream sometimes can disrupt segment continuity or has so big impact on flow regime downstream, take flood wave, retain and make more safely our citizen downstream. And for the fourth, spatial planning, where infrastructure and settlements are located, this determines whether hazards became disaster. And this is very important. This is our decision. And I try to include in actually WFE Nexus framework to put these four sectors. And I try to, with these arrows, show us interaction between all. We see that everything is connected. Everything is connected. And I would like to mention that natural hazard in fifth sector. Just cross-cutting, just like in QGIS, just in the lab. And if we look at how to solve the situation and who will be added maybe to new approach, maybe we need to add spatial planning and civil protection. Maybe we need to think that all our decision and the river basin, accordance with the Water Framework Directive, of course, and all the other directive, maybe we think that this context is just all sectors who need to sit together and maybe, depending on the situation, on our real situation, to add something new, to give some new data, new agencies, so on. We will think about solution when we have a problem, of course, and to share this platform with the other. And this is the reason why I would like to talk more about SDEWES framework. SDEWES framework is very important. SDEWES framework is the global UN disaster risk reduction framework. And this framework gave us something like governance directions. And actually, we need some direction because SDEWES framework also emphasizes understanding risk, what is very important, strengthening governance, reducing exposure, we talk about it all the time, protecting critical infrastructure and improving early warning systems. And this is the reason why I take some target from SDEWES framework and use like checklist and say what SDEWES framework called for. This is reduce disaster mortality, reduce affected people, reduce economic losses, reduce damage to critical infrastructure, enhance national and local strategy, enhance international cooperation, enhance availability of the early warning system and disaster risk information. Put some example from this part of the Union and give some find some implementation. Yeah, I don't want to read, I just want you to say that all of this means that we have so many data, we have so many strategies, we have so many plans on local level, but really we couldn't coordinate, we really didn't coordinate them. Just we had so many plans. In real situation, I could explain in my capital of Bulgaria, we had so big problem with landslide in the city. But if we ask people which live in this area, what will happen if extreme rain fall, like for example in Yalan city, what they do in that situation, they don't know. They don't know. Local level doesn't know about our strategies, and we need to connect, we need to prepare new chain, how to build safely society. And how do we move from this policy objective to operational practice? I put here some policy framework from SDEWES, which tells us what to achieve, reduce losses, strengthen governance, improve early warning, protect critical infrastructure, enhance resilience, and what we should show to our integrated risk management and how to achieve that. We need integrated water, energy, food ecosystem, hazard, and spatial planning. We need to create a shared cross-sectional planning platform, not some imagined platform for acting. Combine monitoring, shared data and risk scenario, support coordinated decision across sectors, implement coordinated risk reduction action. And here I give some operation workflow from monitoring system and sharing data to scenario, cross-sectoral coordination, joint decision using this platform, risk reduction action, and resilient water energy risk system. And so many data everywhere in our countries, but it doesn't connect. We haven't. When you start some new project, in my experience, I always have a problem with data. I always have a problem to collect data and to pass the data, to take new data from every type of project or strategy we do. That we should maybe involve climatists inform hydropower licensing, not only hydropower, maybe for all our engineering infrastructure. Why? Because when we projected some design on some dam, or some dam, usually we use historical data. And when I talk to my students, I say, yes, it's better to have more data. If you have 20 years, 50 years, 100 years more, it's excellent. Because with more data, you could prepare better design of your dam. But what about climate impact? What about future scenario? Do we need to take scenario impact in our design? I think that we need that. Maybe think about some lasting hydropower, because we should use this impact during preparing our new infrastructure design. Next is integrated nature-based solution and engineering solution. I already talked about it, that we need to combine for better effects both of them. Not only nature-based solution, not only rail infrastructure, try to combine all these principles. Then we need maybe harmonize monitoring protocols. I know that in my country, for example, we have synchronized monitoring protocol in all parts of the countries. And how compare if we have some different regulation in one part of the city regarding water quantity, water quality, or whatever? How compare situation, how to make better plan if we haven't harmonized protocols? And climate adaptation need to be aligned with SDEWES and EU policy framework. I think that SDEWES framework and EU policy frameworks are very important and give us some strong tools. And for us depend how we implement that. I think that closing reflection will be made that resilience isn't a technical fix. For resilience, we need technical capacity, and for technical capacity, we should say yes, there is exist because we have indicator, threshold, model, monitoring, this scenario different from different part of the sectors. But they must be connected. We have everything separate. And always surprised when you find some data, some new design, because maybe there exists there somewhere, but we don't know about it. Next, government capacity. Framework exists, but mandates must be coordinated. Water energy spatial planning, climate adaptation, and disaster risk framework must share data, responsibilities. This is very important. Share responsibilities and decisions. And third box is societal capacity. Trust must exist before the event. This is very important. Because local community must be ready, must be prepared for every scenario. How they will prepare because of because of our actions in our government, because of our action at national level, international level, because of all our activities. We should prepare our citizens to be more safely than they are today. And my conclusion is that resilience is water, energy, and natural hazard require technical governance and societal capacity, and to use three of them.
I can start the discussion with one question. When I come, to recent events, basically from last week, I was just checking on internet that France, you gave the example of France. During the heat wave last week, they calculated 1,000 excess deaths only for heat last week. And it was also in London last week, the London Climate Action Week. And one of the experts said that was the hottest London Climate Action Week from now on. Because if we don't take any action, it's just going to get warmer and warmer and warmer. And we also know that we are basically probably going above 1.5 Celsius. We are also overshooting probably in the next 10 to 15 years. So how do you actually see is, changes in weather temperature affecting the region, Southeast Europe, each region, and how should we adapt in this area for extreme heat waves?
Yeah, thank you very much. It's very good questions. When you think about France heat waves, you mentioned that the situation where that in that part of France, that climate effect, that heat wave doesn't know before. And people would surprise. People don't know it doesn't have air conditioning. And this is the reason. They didn't prepare for that situation. And this is the main reason for exceeds that. And this is maybe very important to mention that preparedness is very, very important. We must learn from these lectures. As I told about Venezuela debris flow and mentioned Yablonka disaster, we need to listen, learn from our lessons, but we didn't. We just throw out our lectures, except maybe Japan. I'm not sure. I had so big good experience because working on some project with the JICA in my countries and look at their maps. They have prepared maps for every type of hazards. I don't know if anyone from Spain, but I was very surprised how they designed every possible scenario and how prepared their citizens for every possible scenario. For example, in my country, I will later answer also on the second question. Now we try to prepare for the first time evacuation maps. We prepared to flood directive, water framework directive, and everything. We prepared some flood risk map, but then JICA comes to my country and say, okay, we will prepare evacuation map for floods. We say, okay, evacuation map, but people mostly know where they need to go. But the actual situation is that people don't know. What is mean? It isn't only enough to prepare strategy, to prepare scenario, to prepare maps, hazard maps, different hazard maps. It is very important that conclusions comes to local societies, and local society, every citizen needs to know what can do in situation if you have heat waves blocking in France, if you have droughts, if you have, I don't know, floods, debris flow, every type of hazard. People must be prepared. This is very important.
Maybe a follow-up question on Brazilian aspects. I read some time ago that $1 investment in resilience translates into $4 of benefits or savings, right? So if we had $1 in Bulgaria or Southeast Europe or Bosnia, where should we put that single dollar?
Yeah, I find also $1 if you use $1 to prevent some. They say maybe 7, and someone said 16. We have different answer for that. What is meant? That preparedness is very important because we save losses later. If you know, for example, how drought affected our houses, you need, like French do after drought in heat waves, they change guidelines for building design because they know after long-term periods of drought, we have low pore pressure, derivation of groundwater level means subsidization, something like soil or something like that, and they have so big impact on our building. this is adaptive monitoring. This is very important. Adaptive monitoring, when we talk about disaster risk solution, this is very important. We must learn from our lesson.
Yeah. Thank you. So I want to open the question to the public. Neven, please.
Well, in Europe, we do store quite a lot of water and energy in snow. Because when it's snowing in winter, it keeps in the mountains. This is a very important part of hydrology cycle in Southeast Europe. But we're going to lose snow in the next few decades until the end of the century. And the question is then, how are we going to adapt to that? I mean, we can adapt our hydropower system to that by building bigger dams, but that's extremely expensive, so most probably it won't happen. We will probably adapt in a way that we will increase the size of turbines, so we can capture more electricity in the times of big waves coming. Yes, exactly that graph will change significantly. But then Christian Breyer has shown that with the falling prices of PV and batteries, it will actually become viable to reforest Sahara using desalinated water based on solar PV. It's not going to come tomorrow, but until the end of the century, such an approach could become possible. So these two questions which are on the nexus between water and energy.
Yeah. I don't know, is it a question of consultation of how we could solve that, because it's long-term answering on this question, because this is really the issue. How to improve these balances, because as you mentioned in the springtime, actually under the climate change, now our snow cover is less than before. And if we have snow days, they pass so quickly. And that means that this peak, sprinter peak, what I learned in my elementary secondary school, doesn't exist anymore. Because we don't have so much water in our catchment area. We haven't enough water in our surface. We haven't enough surface water. It was very important for replenishment groundwater, but we're also losing our groundwater with all consequences. And how to solve it will be very, yes, there are so many solutions, desalinization or something like that, but actually problem with water is very important and a very big issue. I need that coordinated action, not only inside boundary of the countries. Emissions must be more introduced everywhere. Maybe coordination between countries better. On the like we have Sava River Basin, coordination of Sava River Basin means actually together decision from Slovenia, Croatia, Bosnia and Herzegovina, Serbia, and Montenegro regarding, for example, flood day or something like that. Maybe that will be solution, working together and share, because we share the same problem with water quantity, but also water quality. When we talk about less water quantity, we also need to think about less water quality. When I show a slide which illustrates on the Danube Basin changes in sediment balance, I forgot to mention that on the Danube River Basin, almost we have everywhere on the places where we investigate heavy metal in the sediment. Heavy metal, what does it mean? We have heavy metal in our river, in our catchment area, in our sediment. A few years ago, I learned my student that floods are sometimes very good because it's nutrient for land. But how I now to say this is nutrient because maybe there is heavy metal, and what are really consequences for agriculture, for health of people, if our land is maybe polluted?
We have time for more questions.
Thank you. Cara Bill from Griffith University in Queensland, Australia. In Australia we have 7 states and territories, all with their own state and local laws and policies. But we've got the same language and the same currency, generally the same government, and we still find it hard to collaborate and work together, as you're saying, in a cooperative way. Now I can imagine in Europe, with different languages and culture and currency and governance and so on, it must be even harder to work together collaboratively. But ultimately, that is what we all need to do, isn't it? Is to work across governments and across countries for it's the same issue everywhere, with the same impact. So I was just wondering, are there examples where there has been some positive collaboration across countries? And you mentioned that communities require trust in the education campaign and the risk preparedness and disaster risk reduction, but I guess that governments require trust between each other as well in order to work cooperatively for a united purpose. It's tricky, isn't it? I was just interested in your reflections.
Yes, yes. Thank you very much for the question. There is a lot, I think that there is a lot of good example in Europe. Actually, in Europe, we have some very important EU directives which are obligated for EU partner countries and countries which would like to become EU partner country. Yeah. And like Water Framework Directive, Flood Directive, Groundwater Directive, so many directives which are mostly transformed through our legislation, which means that we have some framework, general, and told to us what we need to look at. And if we transform our legislation, it is easy to operate because we have some framework. Framework is very important. This is the reason why I mentioned Sendai framework. This is UN framework, and this is important for all these countries. And as good examples, maybe I mentioned SAVA commissions or ICPDR commission. ICPDR is the Commission for Management of Dam River. Through this ICPDR, mostly we share the countries which belong to Dam River, prepare together GIC, HIC systems, and share data, try to cooperate together. For example, now I'm working on 2 project on the Dam River. Very important one is DAM 7 and Q2, which means that we try to make better segment management and to include our result in the next river basin management plan, because this issue is recognized as very important. And the second project is regarding water balance modeling. We tried, it's very famous. At the beginning, I think that it isn't impossible. But through this project, we collect all possible data from all countries of the Danube, make some database, hub of data, do modeling for all Danube, and also modeling on some island zones, and see what will be happening in the actual scenario, and for some future scenario, what will be in the future. Yeah, thank you.
We have time for one short question, one final question. Natasha, please.
You highlighted the role of integrated risk management over water energy hazards. Do you have any indicators how to measure the added value of integration relative to sector-specific approach? For example, in the energy sector, integration means more renewables, ability to integrate more renewables, higher renewable penetration. But how we can measure the benefits of integrated approach in the risk management?
Thank you very much for the questions. How we measure something would be better for our planning system. Usually, we should use some indicator. For example, in actually water balance project and dam management project I mentioned already,
much, Professor Hadžić, for this interesting presentation. We are just in time to close this invited lecture, so please join me in welcoming again and thanking